Yeah, ladies and gentlemen, in this video I want to explain you some data, what we collected, a lot of work copied together and walking through different internet sources, reliable internet sources, because not every internet source is really reliable and trustful. This is a very colored picture, so let me explain what you see here. We collected data almost 3 weeks ago on different resolution scales. This means, first, what you can see here on the axis, we have the incidence, the 7-day incidence, what is the commonly used quantification for infection with corona. And on the x-axis we have the vaccination rate in percent. Okay, so. And we have here, for example, these some parts of Germany, the states, which are these are the blue circles, filled blue circles. Here, this one. And then we had the most a huge amount of data comes from the Czech Republic. There it was possible to get for each city and the corresponding district the data for incidence and vaccination rate. And these are here the Czech Republic data are these filled gray little circles. Huge amount. For Saxony and Thuringia and this one, we have also the opportunity to get for each county in this state the corresponding incidence and vaccination. We cannot retrieve the data for the other states in Germany, but nevertheless at least these three we had. Then we also collected data and have them here, these purple hexagonals, and this gives this amount of data. So what we see here in principle, this is a really funny thing. We have here something like a triangular shape. This is really strange apparently, but there's some logics behind why it's looking that way. Let's go for example here at 50% vaccination rate. We have here a tremendous scatter. We have here incidences starting around 300 going up to 2,000, almost 2,000, 3 weeks ago. Well, this huge scatter comes from several effects. One effect is each state, each country has its own way of reporting it, also reliability or maybe delay, a specific delay in reporting the data to the next level, to the next agency. Okay? So, therefore you have a tremendous variation. There's another effect as well. In the first, second and third corona wave, we already had a significant amount of infections, and the people who were infected, and if it's not so long lasting ago, they have still built an initial defense. The others, well, maybe a certain percentage died. This makes corona so dangerous. Yeah, you cannot really neglect this. For sure not. And this makes this scatter. And another point is this infection was also different from different areas, and corona comes from there was a distribution on Europe. This means not every place at the same time started with the infection. So this means the initial value of infection has also a local variation which causes this scattering. Okay, huge scattering. But what we see, what is evident from this picture, that when we approach higher vaccination rates, you can draw here an upper overlapping line, this black dashed line, and you can plot here another black dashed line that all the data points are above them. Okay. And the funny thing is, both lines essentially have a common intersection point with the x-axis, the vaccination rate. Well, you may say, okay, there's a huge scatter, this is a bit arbitrary. Well, I explained the scatter, okay? But make the following experiment by thought, yeah? Independent of the reporting, if you increase the vaccination rate and increase the vaccination rate, and when you come to a certain level of vaccination rate, independent of the way of reporting and the initial value, you approach for sure a incidence of 0 or almost 0, because even in vaccination it's not 100%. Even a certain amount, a certain percentage, 0 point something percent, yeah, there you have a breakthrough where the vaccination holds not. Nothing in your whole life is for sure, for 100%. Even when you decide in the morning, take out the bicycle out of the garage, drive to work by bicycle, yeah, you stay healthy, yeah, fresh air, you move your body, yeah, you exercise a bit, but there's a certain percentage that you will die on your way with your bike to your work. Yeah, there is nothing 100% sure, safe. Yeah, no, nothing. There are only probabilities. Yeah, there is no 100% guarantee. Well, we all are seeking for 100% guarantee, but this is a illusion of human beings. Yeah, and a bit stupid. So, in principle, you better have to massage your brain a bit and think about. It's all in your life. It's a bit of probability. Even when you decide to marry, there's only a probability that this stays for your whole life. Yeah, 30% of the marriages are divorced. Yeah, so it's the same issue. Yeah, probability. So, but and even when you have these strong case here, when you more and more vaccinate the people, independent on the reporting, you should approach 0. So bad reporting line here, excellent reporting, or very many people have a contact with potential corona. But when you increase the vaccination, even bad and super reporting, both lines should have a common intersection point with the x-axis, the vaccination rate. And the funny thing is, this is at 92%. We have actually a vaccination rate in Germany something around 70%. Yeah, don't discuss about 68 or something, but we have areas in this country 40 something percent vaccination rate. This is really horrible. Yeah, and it should be part of every night prayer. Go to vaccination. We must reach the 92%. We must have the 92%. Yeah, and we should booster afterwards. And in the next, it's like influenza. In the next few years, the experts have to adapt the vaccination to a modification or to the mutants of these coronaviruses. This is very important. But the 92% from this data, this is evident. Even if it's 91 or 93, yeah, I can also make here a calculation about the reliability with 95%, but don't discuss 1%. Yeah, 90, for sure it's between 90 and 95%. We must have this. Be part, yeah, talk to people, yeah. Take home message 92% or 91 or 93, don't discuss that, but this is evident here on this picture. Okay, thanks.